yesterday, what did we say linear means? Do you remember? Straight line, remember? What about a function? What was a function again? What did we talk about that? You got here? Put something in, you get something out. We talked about a few different regular function machines we see every day. Washing machine, right? Pop machine, toaster. What was that? Humans, people. Calories and energy, studying and getting your grade on a test. What's that? A plant? Okay. Get water and it grows, I suppose. So, a lot of different functions. So, we're going to deal with straight lines today, and we're going to deal with functions. So, two vocab words I have for you are linear equation and linear function. Linear equation, linear function. Notice that linear equation and linear function are about the same thing. They both form straight lines. Anything that has linear in it is a straight line. The difference, remember yesterday we talked about functions and equations, is what you just know how to solve. And remember the function, they just tell you what x is in a different format. Remember that from yesterday? I'm going to explain that bottom part. You don't have to if you don't want to. I'll explain it. Alright, so my little tidbit of information here, it says if it's truly linear, something's truly linear in a straight line, there's a constant change between your x and your y, and you're like, what does that mean? You remember last year when we talked about number of pizza and cost? It was like 1 pizza 6, 2 pizzas 12, 3 is 18. Remember that? Okay, so this, if I would graph this, it's going to be a linear equation because why? What keeps happening? It's constantly changing by what on this side? 6, and what's it constantly changing on this side? So that's what this means. If there's a constant change on both sides, it's going to be a straight line. Remember we talked about this last year? A little bit, like making charts and filling in charts a little bit, maybe. So it's kind of like in proportion, yeah. So if it's in proportion, it's also going to be a straight line. Yep. Alright, so what does this mean? How are we going to use this today? So let me show you. Remember yesterday you were given a function and you had to put something in, like if it said f of x is 3 and you put it in, you got something out, remember? Okay, so we're going to do the same thing. So this is like our function machine. This is our function. That's what we're going to use to put something in and get something out. Now let me explain how this is going to work. What you're going to do is you're going to make a big chart that looks like this. Okay? And one side here is going to be x, and one side is going to be y. In the middle, you're going to put your function machine, or your function. Now, this part is actually the easiest part you will ever have in math, because how often do you get to make something up yourself? Not often. This is one of the only times you ever get to make something up yourself. You get to decide what you put into that function. But I'm just going to give you a little hint. Have you heard the term KISS? Keep it simple, stupid? Have you heard of that before? Okay, so you're going to keep it very simple. Okay? I mean simple. What are the simplest numbers you know? 2, 1, 0. Okay, you're going to use those in your x. And here's what I suggest. I suggest you use a -1, a 0, a 1, and a 2. These are the easiest numbers you know. And you might say, well, -1, that's not easy to me. But think about it this way. If I have to graph this in the end, let's say I graph this, my x's are over here, it's going to look like this. Now when I graph a function, I really want it to go over a few different quadrants, and so that's why I have to include that -1. It's going to take it over another quadrant, okay? And we're going to have to graph later on. So that's why I'm always including -1, right? Then what you're going to do is you're going to take your function machine and your x, and you're going to write exactly what you're putting in for x. So decide you put -1 in that time. This time, you're going to put 0 in. This time, you're going to put 1 in. This time, you're going to put 2 in. See what we did? We just took where we decided x was. Now we're putting it in for it's the function machine. It's happening right here like your washing machine's washing, whatever. And let's say now you have to find your answer. So what's 7 times negative 1? Negative 7. What's 7 times 0? Okay, so that's what just happened. We put this in, your function machine worked, and you got something out. Then it's going to ask you write as ordered pairs. Well, your table gives you your ordered pairs for you. Your first order pair is going to be negative 1, negative 7. 1, 7. Your second one's going to be 0, 0. Third is going to be 1, 7. Your second's going to be 2, 14. That's your order pairs. Now listen, if you start doing something here and you're getting some answers, what are you noticing about this side? Is there a pattern? Okay, there's always going to be some kind of pattern here. If there's not a pattern, let's say you go from 1 to another 1 to a 3 to a 6, something is incorrect. So go back and relook. So you're always going to have some kind of pattern on this side. All right? Remember when I talked about the pizza and how much it cost? How there was a pattern on both sides? You should have a pattern on both sides here. Okay? All right, let's go to the next one. Let's do this one. Okay, so here's your function. And you're going to make your chart. I would. Some people can get to the point where they don't put the function part in it, but I suggest you do that so you can actually see what you're doing. Because some people will say, well, I don't need to see what I'm doing. I can just do it in my head. It doesn't work very well. So just stick with this for now. You might get to the point someday where you do not have to do that. That's fine. Well, you can try if you want. I was just going to wait for you. If you want to go ahead and try, you most certainly can. If you aren't sure, remember, okay, now this is going to be my x. Now I'm going to put that in for my x, and I'm going to solve. No, there's more to this. There's more to this. I'm going to show you how to graph. You do have to graph a few of the problems, like 4 of them. Yep. So once you do this, so this is negative 2 plus 1 will be negative 1. This one was 1. This one was 3. This should be 5. But number 2. So then make sure, I know, you thought, oh, no, you're right, it's right. Yep, and then write in your ordered pairs, make sure you get those written too. Any questions so far? Where do you think this is going to go next? On a graph. Okay, but before we do that, I'm going to do a special one with you on a graph, okay? We're going to actually do this one together on the graph. Is that all right? Sure. Okay, so first thing you're going to do is you are going to make your table for this function. Because you have to have some ordered pairs to be able to put it on your graph. So, make your table for your function. And be careful, because you're subtracting here, and you're going to have to keep change for, I think, 1 or 2 of these. Bless you. first one would be negative 3 minus 4 would be negative 7. Yep, and then you can graph it, and then you would graph these pairs. So like this first one, you do negative 1, negative 7. Do you guys remember how to graph? Not really? Honestly? So if this is my first point, I'm going to go, remember it goes positives this way, negatives this way. I'm going to go x was first. I'm going to go to negative 1, and then I'm going to go down 7. 1, 2, 3, 4, 5, 6, 7. That'd be my first step. My next one is going to be 0, negative 4. So I can't go anywhere, so I'm going to go 1, 2, 3, 4. And my next would be 1, negative 1. Be right here. And then 2, 2, 2, 2. And if you graph them, it should be a straight line. It should be. This doesn't look very straight, but it should be a straight line. Linear, straight line. They should all be straight lines. Okay. What do you notice? It's kind of interesting because what do you notice? They're like perfectly spaced, right? Like up 3 over 1, up 3 over 1, up 3. Do you see how it's consistent? And that's going to lead us to slope in a few days. Oh yeah, we are. We are. Questions so far? Not yet. Yes. Yep. Questions so far on how to do this? So far, so good? So making your chart, you choose what you want for your x's, keep it simple, put everything in, get it out, and then if it asks you to graph, you need to do that. Not all of them are going to ask you to graph today. There's only like 4 in the end that do, so don't think you have to graph all of them. Okay? All right, so 2 other vocab I have. X-intercept and Y-intercept. This is starting to lead us to slope. This is something you're going to have to know for slope. Okay? X-intercept is where your line, let's say if you draw a line, where your line would cross the X, and Y is where it would cross the Y. So that's why another reason we have to put that negative 1 in there, because if we don't, sometimes you won't see your X-intercept. Okay, so that's why we also have to have that negative 1 in that graph. So let's say I have a dot over here, and I said, well, what's the y-intercept? Well, my y-intercept would be 3, because that's where it's crossing the y. Here, if it's on the x-axis, and if it's my dot's here, my x-axis should be, or my x-intercept would be 4, because that's where it's going to cross the x-axis. What's that? No, this is just an example. So let's say I have a dot right here, and this is on my y-axis. Where is my y-intercept? If I would draw a line, let's say I draw a line like that, what point is this crossing the y-axis at? Well, right where this point is. So I'm going to count 4 down. 1, 2, 3, 4. So my y-intercept here would be negative 4. So I'm just looking at the point that it's crossing the y or the x. That's it. So let's say I cross it here perfectly on the x. What's my x-intercept going to be then? 1, 2, 3, 4, negative 5. So I'm just looking at that point that it's exactly crossing those lines. That's it. Okay? You want me to do another example? Okay. So let's say this one and this one. Okay? So my y-intercept is just 1. And my x-intercept would be Right, so it's just simple. It's just where it's crossing the y and the x. That's it. Okay? And if you aren't sure, make sure you label your graphs. That'll help you figure out what's what. Okay? So far, so good? Okay, I'm going to stop now, and I'll come back when we come back at 3 o'clock, and we'll continue the rest of it. Okay? See, I think I... All right, so the next thing I'm going to show you is something you're going to need for slope. Okay? And you can use this in your homework today. There's one spot where you can use this. So, what's going to happen is before, when we were given a function, we had to make a chart to figure out the graph and whatnot. But now, there's actually a way you can do it where you can figure out from that function where it's going to cross the x-axis and where it's going to cross the y-axis. And that's the only two things you need to plot then, because that makes your line. Really, you only need 2 lines to make a line, or 2 dots to make a line, right? To connect them? Okay, so this is an even easier way to figure out where your line is on your graph without making your chart. Some of you might like it, some of you might not, and that's fine. So, yep, and I'll talk about that later. Yep. You will have to do that in a little bit in your homework. There's a place you're going to do that in your homework. There's a place where you can use this in your homework. But you could also use the chart. It's going to give you the same answers. Not necessarily. No. Yes. Graph something. You have to be able to have points to graph something, right? So you don't have to use this. You could still use the chart if you wanted to. But you might actually like this better. I don't know. Okay, so here is my function. Okay? And my job out of this function is to find where it crosses the x-intercept and where it crosses the y-intercept. So what I did is I make a chart, because for me it's easier to see in 2 sides, because otherwise it gets way too confusing. And if you have it a chart, it makes it so you can easily find your work. So a few things you probably need to write down is for your x-intercept, you want to find x. Okay? And then the next thing is the big thing. You're going to put 0 in for y. And this is for every single one you're going to do. You're always going to use 0 if you're using the intercept. And then you're going to solve. Because if we're finding the x-intercept, we can't put anything in for x because then it gets rid of x. At the end, you want to say x equals something. So I'm going to go to my function, and I'm going to substitute what I'm going to substitute. So x is going to be plus, what am I going to put in for y? 0 equals 4. So if I minus 0, what's x going to be? 4. Okay, so I already found where it's going to cross the x. Now I'm going to do the y. So this time I'm going to find y. And what do you suppose I'm going to do with the x this time? Put 0 in for x. You're always going to use 0. This time you're not going to go back here. Okay, I guess you could if you wanted to, but we're not going to. And then I'm going to solve. So it's going to be, it can be, not all the time, but it can be. So if I'm going to solve for y this time, I'm minus 0, what is y going to be here? Okay. So I know now where my x and my y are going to cross. So if I would graph this, say this is my graph, and this is my x, and this is my y, I'm going to find my x, and I'm going to plot where 4 is, because that's my x-intercept. My y-intercept is what? I'm going to plot my y-intercept, and guess what? That's what my line's going to look like. Yep. Like this one up there. You wouldn't have to. I'm just showing you a simple one. I'm just showing you how it works first before we get into more harder ones. Okay? So yeah, if I would actually make my chart of 4, guess what? My line would be the same. My line would be exactly the same. All right, let's do another one. Here's my next one. My function is negative 2x plus y equals 4. This is a trickier one now. A chart like this. You can use an x-intercept. You can use intercepts on this. So for your x, what are you going to put in? You're going to put in for your y, right? So it's going to look like this. for your y. Then you're going to solve. Minus 0, minus 0. Get 2 at negative 2x equals 4. Everybody's doing it? You get negative 2 for your x. That's what you should have gotten. And then for your y, you're going to do the same thing. Only you're going to put 0 in for the x this time. And you want to keep your y. And then you're going to solve for what your y should be this time. So negative 2 times 0 is 0. So really it's 0 plus y equals 4. And really what's y equal again here? Equals 4 again. Right? So now if you were to graph this, you can make your chart x, y, or your graph. And so your x would be here, right? Because that's negative 2. And your y would be here. Does everybody understand how I know where they go? And then I make my line. So it's actually just a simpler way without the chart of 4. That's all. Any questions for me? Do you want to do it? One more? Okay. And I'll let you do it. Sound like a plan? All right, so let's do 2x plus y equals 6. Good job. Nice work. Nice work. That's about done? Did you get your x-intercept? Where does it cross at? 3. Nice work. So if I was going to graph, this is my x, 1, 2, 3. That's where the first one's going to cross. So what about that y? 6. Good. So my y, 1, 2, 3, 4, 5, 6. That's where it's going to cross. That's what my line's going to look like. That's all you do. This is it for today. Oh. Oh, yeah. Sorry. Yeah, your answer would be wrong. Okay, so any questions for me? Honestly, I'm going to tell you right now, Mr. K and I were talking about this. Mr. K, that's funny. When I were talking about this in the hallway, he said this is the hardest thing for kids to get in Algebra 1. One of the hardest things. Seriously. So, keep your notebook for next year. I'm not kidding. Keep your notebook. Keep your notebook, because this could help you. Oh my gosh, Maddie. I got to shut this up.